Hello and welcome to my math tutorial. Today we'll talk about congruent triangles that are simplified, definition of congruence that is simplified, and 5 different types of congruence, namely SSS, SAS, ASA, AAS, and HL that are also, you guessed it, simplified. We're also going to look at some problems. So don't forget to subscribe and hit the like button. Let's get started. What is congruence? Congruence by definition implies exact form, same shape and size, identical, equal, and so on and so forth. So for two triangles to be congruent, both need to have equal corresponding angles and corresponding sides. What do you mean by corresponding? If you copy and paste one triangle, the other triangle is an exact replica of the first triangle, and both are considered congruent. No matter how they are oriented, they can be flipped, they can be rotated, they'll still be congruent. Now let's take a look at different types of congruence, starting with side, 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 or SSS. So what does SSS mean? This means that two triangles are congruent if they have exactly equal corresponding side measures, or they're exactly the same, copy and paste of each other. Okay. I have made a triangle with 3 cardboard pieces that are joint at the vertices, and the joints are movable as shown right here. Although the joints are movable, the shape is locked and cannot change. Thus, if you happen to have another triangle with the same corresponding side, then both are congruent. So here's actually my triangle. As you can see, there are joints over here. So I have these joints right over here, and I'm going to make the third join over here. If you can see this triangle, although the joints are movable, you can't change the shape. This is unique. These 3 sides will never have any triangle that doesn't look like this. So, if you happen to find another triangle that has the same measure of sides, side, 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 both are congruent. Look at that. There you go. All right, now the next property. The side angle side, or SAS property. Okay, this property states that, ready? If two sides and an included angle of a triangle are congruent to the two sides and an included angle of another triangle, then both are congruent. Simple. Translation. If this piece of triangle measure is the same as this piece of another triangle, both are congruent. Simple as that. So in our example for side angle side, if you look at these two triangles right here, so we have a side, we have an angle, and we have a side. Side, angle, and side. If this side is exactly the same length as this side, this angle is the same measure as this angle, and this side is the same length as this side, then both are congruent. That means the third side has to be equal. The third sides and the two angles have to be equal. That's what side angle side implies. Okay, now let's take a look at angle side angle, or ASA. So ASA, or angle side angle, implies that if two angles and an included side are the same for two triangles, are exactly identical, same measure, then both are congruent. Let's take a look at this example right here. Okay, so if this angle right here, angle, is the same angle as this angle, this side is the same measure as this side, and this angle is the same measure as this angle. If these 3 conditions are met, then automatically this angle is going to be the same as this angle, and this length right here is going to be the same as this length, and both are going to be identical, equal, or congruent. So that was ASA. Now let's take a look at the angle side property, or AAS. The angle side property says that if two angles and a non-included side, very important, it's not ASA, it's AAS, so not the included side, but the side which is away from the angles. Okay, if they are equal for two triangles, then the triangles are congruent. Then it automatically means that the third angle and everything else is exactly same for both. Let's take a look at these two triangles again. Now over here, AAS states that if this angle, and this side for this triangle is the same as this angle, and this side right over here, then both are congruent. Simple as that. And finally, let's talk about the HL, or hypotenuse leg postulate. This states that if the hypotenuse and leg of a triangle are congruent to the hypotenuse and leg of a second triangle, then the two triangles are congruent. Okay? So to recap, we went through 5 different types of congruence, namely SSS, SAS, ASA, AAS, and HL. Okay? Now let's take a look at some problems. Let's get started. Let's look at the first problem. This shows a triangle XYZ W. We have been given sides XY and XW equal and YZ and ZW equal. So the question is, how do you prove here that XYZ and XWZ are congruent? Over here, we need to satisfy any of the conditions from the different properties or postulates of congruent triangles. Let's look at the two sides. We have been given sides XY and XW equal and YZ and ZW equal. That means we have an SS condition so far. We do not have an SSS. If you notice, XZ equals XZ, reflexive property. Hence, we have all the three sides equal. So it's an SSS congruency postulate or property, and therefore XYZ and XWZ are congruent. Okay, let's go to the next problem. In this problem, you've been given this figure LMNO, where LO and MN are 9 centimeters. LM and ON are 17. So what do you do over here? You have been given a 25-degree angle over there. The question here is find angle MLN and explain how you determined its measure. Now what does that mean? What is MLN? So as you can see, we have to find this angle right over here. So if any two triangles are congruent, then definitely their corresponding angles will be the same. In this case, you have LO is MN, which is 9. LM and ON are 17. And LN and LN are the same. So it's side, side, side. And hence, both triangles are congruent. And their corresponding parts show MLN is also 25 degrees, similar to LNO. So that solves the problem. Now let's take a look at this third problem. ABEDC or ABCDE. Over here, E is the midpoint of both AC and BD line segments. Prove that AEB is congruent to CED. So over here, we've been given two sides, if you can see. If you can take a look at the triangles in the figure, AE equals EC and DE equals EB. So we have two sides. Can we find a third side? Can we do SSS? I don't think we can. But we can definitely see that angle E has vertical angles. So AEB angle would be the same as DEC. So in this case, we have side angle side congruence, and both the triangles are congruent. So thank you for watching this tutorial. If you have any problems or challenging questions related to congruence, please mention in the comments below and I'm going to try my best to help you with that. Don't forget to subscribe to my channel and to smash the like button. Until next time, thanks a lot.